Hey viewers, welcome to Science Spectrum with Don. Welcome to Maths 188, the fundamentals of mathematics. And this will be the sixth part of the first lecture. So we'll proceed, with a few more things in proportion. All right, so I may need to solve a few questions in proportion. Then we'll talk about the properties of proportion. Then I'll wrap it up, for the first lecture. All right, so just a quick one. I have a question. Let's say we have several taps, There are several taps, that rush at a constant rate. So we have several of them. So let's say, for example, if it takes 4 taps, it takes 4 taps, 10 hours, to fill up a container. The question is, this, how many hours will it take 6 taps, to fill up the same container if the taps, rush, at a constant rate, So that's just the question. But I would maybe point out a few things to you here. If you compare these quantities, taps, number of taps, to the time, it takes for those taps to fill up a container at a constant rate, there is really an inverse relation, between the number of taps to the time. How? If it took 4 taps, 10 hours to fill up a container, then it simply means when you have more of the taps, it will take lesser time. So we could really solve this with proportion. So I would say, so simply I would take the ratio of, the number of taps. So it is, ratio 4 to 6. But we do know that as 4 is to 6, ratio 4 to 6 is as, the ratios of the timing now. But I may need to flip the time because there's an inverse relation, between taps and the time. So instead of sticking in an X, a 10 here, I would stick in an X here, and I'll bring the 10 down. Why? Because there's an inverse relation. The more the taps, the lesser the time it takes to fill up that container. So this is, X to 10. That's it. So 4 is to 6 as X is to 10. That's, what it's all about. So we actually look out for X. So 4 is to 6 is 4 over 6, is equal to X over 10. Alright? So 2 in 4 is a 2, 2 in 6 is a 3. So I'm left with 2 over 3. This is equals to X over 10. And of course, since I have a pair of ratio on the right and on the left, I could easily cross multiply since there is no factor, that these values could divide. So X times 3, would give me a 3x, and then 2 times 10 is a 20. So I could divide both sides by 3 to find the time it takes for 6 taps, to fill up that container at a constant rate. So x becomes, this is 20 rather, this is 20. So x becomes 6 whole number, 2 over 3 hours, Or you could say x is just 6.7 hours. Let's say this is 6.67 hours, as you like it. So it will take a lesser time for more taps, if they were to be rushing at the same rate. Alright, so another question, you need to beam this for a while. I may likely rub this up sooner. So another question I may want to talk about in proportion is the next example now. So the next example I will talk about is, let's say it takes, now I'm comparing the number of units consumed, that's electricity, to the number of days, that it was used. So let's take, for example, let's say it takes 18 days, to consume 200 units, of electricity. So the question is this, in 30 days, how many units would be consumed? That's just the question, And if the consumption were to be at a constant rate. So straight to the point, I may need to wipe this part off now shortly. Alright, so straight to the point. Now, the relation between number of days and number of units consumed, okay, is actually a direct relation. Why? Because the more the days, okay, the more the units that will be consumed, and the lesser the days, the lesser the units, okay, that will be consumed. So this is just a direct relation. Alright? So this is so I will take a pair of this ratio now, okay? Okay, 18 to 30 is as 200 to, is as 200 units, okay, to XY, because there is a direct relation that exists between them. So you could see 18, okay, days would require, okay, would consume 20 units, 200 units, then 30 days, okay, we are looking for the number of units that will be consumed in that day. So this will be written as, I could write this as 18 over 30 is equal to 200 over x. Alright, so let's see, 3 could go here, of course 2 can go. So 2 in 18 is 9, 2 in 30 is 15. Of course 3 could still go, 3 in 9 is 3, 3 in 15 is 5. So I'm left with 3 over 5 is equals to 200 over x. So I have a pair of ratio on the left and on the right, so I could easily cross multiply. 3 times x will translate to 3 times x will translate to 3x. And of course, 200 times 5, 2 times 5 is 10. So I have 1,000 here. So I could divide both sides by 3, okay, to find out the number of units that will be consumed in 30 days. So x becomes 1,000 divided, okay, by 3. And you get, when you divide 1,000 by 3, this is 333.3. So this will be 333, okay? Let's say 0.3 units. So what this simply means is in 30 days, okay, 333.3 units, okay, of electricity will be consumed. All right. So these are the few questions I would want to, okay, solve in proportion. Now, proportion has properties. There are properties, a few of them. So let's talk, okay, about a few of these properties of proportion, and I'll wrap it up for the first lecture. All right, so we need to bring this for a while. So the properties of proportion, let's talk briefly about them. Properties of proportion. Properties of proportion. Okay, I talked about a few of them from the 5th part of the first lecture. So let me talk, okay, about the rest. Now, if I have okay, an equality of two ratios, which is called proportion. So let's say A is to B, okay, ratio A is to B as, okay, C is to D. This is an equality of two, okay, pairs of ratios. Now, I could write this as A over B is equals to C over 80, right? Now, I could invert these ratios. I could invert. Inverting means I could flip each pair of the ratios, okay? So when I invert, okay, inverting, okay, the pairs of ratios, and by the way, this is the first property, okay, inverting the pair of ratios, so once I flip this over, okay, this term would come up, okay, I'll flip this, I'll get ratio B to A, okay, it's as D to C. So we could really invert, okay, ratio. So let's take for example, if I have, let's say, ratio, okay, 6 to 7, okay, is as 12 to 14. I could write this as, okay, 6 over 7 is equals to 12 over 14. Of course, nothing has changed, okay, when I flip this, so I'll get 7 over 6 is equals to 14 over 12. And of course, it's the same thing, okay? So when you invert ratios, okay, nothing is altered. Now, the second property is alternating of ratios. So we could alternate a pair of ratios. So number 2 is alternating a pair of ratios. So let's take, for example, I have okay, A is to B as C is to D. Alright, so I could write this as A over B is equal to C over D. So how do I really alternate? So alternating, okay, this pair of ratios, alternating this pair of ratios simply implies this, okay? So how do I really alternate this? I could multiply each of these pair of ratios now by, okay, B over C. So the first pair of ratio is A over B, and okay, I could multiply that by, okay, the second, okay, and the third pair, so that is B over C, and then this is equal to the second pair of ratios, C over D, okay. I could multiply that, okay, by B over C. So definitely the B cancels out and the C deletes out. So I'm left with A over C is equals to, okay, B over D. So I've alternated this ratio. So this same ratio, okay, this same proportion could be written as, okay, A is to C as B is to D. They mean the same thing, okay? So you could check that out with this example I gave. All right, now the third thing, the third property, can I clean this up? So the third property of ratio I want to talk about is when we add 1 or we subtract a 1, okay, from a pair of ratios, okay? That's an equality of a pair of ratios. Let's really see what the outcome will be, okay? So that is the third one. So I have A is to B as C is to D. This is proportion. All right, so this is written as A over B is equals to C over D. So I'm adding 1 to both sides, okay? Now, the moment I do that, the moment I add 1, okay, you can say 1 over 1 to both sides, it simply means the outcome of this, okay, is what we'll call the components, okay? I'm taking the components, okay, of this proportion. So definitely this is, I'll get A plus B out of this over B, okay? This will be equal to C plus D, okay, over D. All right, and of course I could write this as, this will translate to, okay? This will translate to, okay? A plus B is to B, okay, as C plus D, okay, is to D. So this property is called component. So I could take the component, okay, of a proportion. Now the next thing I want to talk about, and for those watching who may not really know how, okay, I came about this. So let me pick it up from here, okay, and so I have A over B plus 1 over 1 is the same thing, is equal to C plus 1, okay, C over D plus 1 over 1, okay. So this is, I'll take the LCM of B and 1, that's B. So, and once I do that, I have B in B is 1 times A is A. I'll stick in the plus sign, B divided by 1, okay, I'll get a B. Then that B times 1 gives me a B. That was how I came about, okay, this time. The same goes with this. The LCM of this is D. D in D is 1 times C is a C. Stick in the plus, D in 1 is D. Then times 1, okay, I'll get a D. So that was how I came about this. Now, the fourth part of the property I'll talk about is simply, we can divide, okay, it's called actually, okay, the dividend, okay, of a pair of ratios. So let's say I have number 4, A is to B as C is to D. Now the moment I subtract, this is A over B is equals to C over D, okay? The moment I subtract 1 from both sides, minus 1, and I subtract 1 from both sides, okay? Definitely, the moment I do this, okay, I'm taking the dividend, okay? The dividend, I'm just taking, okay, it's a dividendal property. So what I have is A minus B over B, okay, is equals to C minus D over D. All right, now fifth part, okay, of this property is, what if I have A is to B as C is to D as E is to F, okay, and I multiply by a positive non-zero digit or number, L, M, and N. So definitely what I'll get is I'll get LA plus MC plus NE divided by, okay, this time, that's LB plus ND plus NF. And of course, that's it. Then you could take the components, okay, and divide by, okay, the dividend. Then you could get this term over this term over this. Why? Because the B and the D, okay, cancels out. All right, thank you for tuning in.